Welcome to lesson 5, Ohm's law. Typically this is written as I equals V over R, but in grade 9 we're going to use the formula V equals IR. So just a little bit easier. Ohm's law is a formula that relates the current flowing in the circuit to the resistance in the circuit and the voltage being applied to that circuit. If we know two of the three variables, we can solve for the third using this equation, V equals I times R. We will complete 3 examples in this short lesson. Then you will move on to the assignment found in the booklet for this unit. Be sure to show all your steps, as each step is worth marks. If all you write is the answer, your mark will be 20 to 25%. In order to get 100%, you must show all the steps that will be outlined in the examples. The answer sheet will be out for you while you work on the assignment in class. Check often to make sure you are on the right track. If you are not done before the end of the period, be sure to complete it as it is homework and check your answers before class tomorrow. There is a quiz on Ohm's law at the beginning of class tomorrow, as well as a homework check, unless otherwise specified by your teacher. The strategy. First, we will list the variables. Then we write the formula that we are going to be using, which is always V equals I times R. We will have to rearrange the equation so the unknown variable has been isolated. After our unknown variable is isolated, we substitute numbers into the equation. We then solve it by punching it into our calculator. Then we must finish with a statement, a full sentence that includes all the variables. Example 1. What is the current in a circuit that has a light with resistance of 6.4 ohms that has been hooked up to a 4.0 volt battery? The first step is to list our variables. Already in your booklet it says I equals V equals and R equals. On the quiz these will not be given to you, but this is the first thing you'll want to do. List your variables. The question says, what is the current? In a previous lesson, we learned that current is symbolized by a capital I. So we will put a question mark next to the I. The question says the light has a resistance of 6.4 ohms. Also in a previous lesson, we learned that resistance is symbolized by a capital R. So next to R, we will write 6.4 ohms. It also says we have been hooked up to a 4-volt battery. So next to the V, we will write 4.0 volts. Step 2 is to write the formula, then rearrange so the unknown variable is isolated. So here we write down V equals I multiplied by R. We are looking for I, and I is not alone. So what I mean by isolate your variable, we need to rearrange the equation so that I is all by itself. But I is not by itself because it is next to R. And if they are side by side, what are they doing? Well, when numbers are side by side, they're being multiplied. So if we want to get I by itself, we have to do the opposite of what R is doing. If R is multiplied by I, we will divide both sides by R. Now that I see an R on the top and the bottom, on the right-hand side, I can factor those two variables out because anything divided by itself is equal to 1. Since both R's factor out, that now leaves I by itself, and that's what I wanted. I'm looking for I want to isolate I, so I need to get I by itself. So on this side of the equation, I see I have I all by itself. And on the opposite side of the equation, I see that I is now equal to V over R. So I equals V over R. Now that I have I by itself, I can substitute numbers into the equation. V is 4.0 volts, R is 6.4 ohms. So 4.0 volts goes on the top, 6.4 ohms goes on the bottom. I will now solve by placing it into my calculator. So 4 divided by 6.4 equals 0.625. And I was looking for current, so I have to make sure that I put an A after the 0.625. Note that every single time I write a number, I need to have a unit behind it. I is always measured in amps, V is measured in volts, and R is measured in ohms, so I have to put that omega sign. I'm going to finish by writing a statement. I'm going to take the question and I'm going to turn it into my statement. I decided to cross out what is and then change the back half to is 0.0625 amps. So the statement will read, the current in a circuit that has a light with resistance of 6.4 ohms that has been hooked up to a 4.0 volt battery is 0.625 amps. So the last thing I do is write that entire statement out, making sure that all of my variables are inside of the statement with their values. Example 2. What is the voltage of a battery if that battery can push a current of 1.5 amps through a 6 ohm resistor? Again, I start by listing my variables. The question says, what is the voltage? So I know I'm looking for V. So I'll put a question mark next to V. What is the voltage of the battery if the battery can push a current of 1.5 amps? It says the current is 1.5 amps, so next to I will put 1.5 A. What is the voltage of a battery if that battery can push a current of 1.5 amps through a 6 ohm resistor? 6 ohm resistor, R is resistance, so I will write 6.0 ohms next to R. Now that my variable list is complete, I now write the formula, then rearrange so the unknown variable is isolated. So the equation for all these questions is V equals I multiplied by R. Now what do I do to get V by itself? Well, that's a trick question because V is already by itself. V is equal to I multiplied by R. So I will substitute in 1.5 amps for I, 6.0 ohms for R. Now I will solve by punching the numbers into my calculator, and that will give me 9.0 volts. The last thing I need to do is write a statement, a full sentence that includes all the variables. So I will take the question and I will change it into my statement. I drop the first half, what is the voltage of a battery if that battery, and replace it with a 9-volt battery. So it now reads, a 9-volt battery can push a current of 1.5 amps through a 6 ohm resistor. Now, for the final example. Calculate the resistance of a circuit that has 3.6 amps running through it and the battery has 9 volts. Again, the first thing we need to do is list our variables. Already in your booklet, it says I equals V equals R equals. The question says calculate resistance. Resistance is an R, so I'll put a question mark next to R. It says 3.6 amps, and we know that current is measured in amps, and the symbol for current is an I. So next to I will write 3.6 A. And we are told that the battery is 9.0 volts. So next to V, voltage, I will put 9.0 volts. Now that I have my variables listed, I will write the formula, V equals I multiplied by R, and then I have to rearrange to isolate my unknown variable, which is R. Now R is not by itself. I is next to R, and if they're side by side, they're multiplying. So again, if I want to get I away from R, I will have to do the opposite of what I is doing, which is division. Since I is multiplying by R, I will divide both sides by I. Once I have an I on the top and the bottom, they will factor out, leaving R by itself. Now I have R all by itself, just like I want. I wanted R to be isolated. So R is all by itself on one side, and on the opposite side, I have V divided by I. So R is equal to V divided by I. Now that I've isolated R, I can substitute numbers into the equation. V is 9.0 volts, and on the bottom is I, which is 3.6 amps. Now I can solve by placing 9.0 volts divided by 3.6 amps into my calculator. And that gives me 2.5 ohms. So R is equal to 2.5 ohms. Now make sure that you note every single time I have written a number, it is always followed by a unit. On the quiz, you have to make sure that every number that you write has a unit that follows that number. Now to finish off, I have to write a statement. So again, I'm going to try to think of some way to change that question into a statement. The resistance of a circuit that has 3.6 amps running through it and the battery has 9 volts is 2.5 ohms. This could be written a number of different ways, so obviously your statement won't be the same as mine. I could have written, if the current is 3.6 amps and the voltage is 9.0 volts, the resistance will be 2.5 ohms. Or there is a resistance of 2.5 ohms in a circuit that has 3.6 amps running through it, and there is a 9.0 volt battery connected to that circuit. Just as long as all your variables are listed with their values inside the statement. So complete the assignment in the booklet. There are 10 questions. I would check every 3 to 4 questions to make sure that the answers you are getting are correct. If you are not getting the answers found in the student answer key, you want to find out why. There will be a quiz on this next class unless otherwise specified. There will also be a homework check, so make sure the entire assignment has been completed.